Right, question 7. An object of mass 2 kilogram is placed 30 centimeter directly above the top end of a vertical spring. So the spring constant is given as 2000 Newton per meter. We have to calculate the speed of the object just before it strikes the spring, and lastly the maximum compression lah. Alright, so first what are we gonna consider is there's gonna be two situations to this what is happening here lah. Okay, so firstly the block is firstly we have to define a reference line lah. So I would say our reference line will be there. So if the anything that is on this reference line will be equal to 0 lah. Okay, alright, so now wait, let me just redo that. That's okay, that's better. Alright, now for now let's just see what is being experienced by this block here lah. Okay, so first this object is placed just right above, so it is placed, so it is not thrown, so the initial velocity should be equal to 0. So if the initial velocity is equal to 0, the kinetic energy should be equal to 0 lah. Okay, next what do we need to see? We need to we also have this this block is also experiencing a gravitational potential energy. So we can write this as 0.3 meter. It is positive because this is above the reference line lah. Okay, so why did I write initial? It is because this is the initial situation. Okay, after that baru dia jatuh. So at the point yang dia jatuh tu, at the point here, contohlah dia jatuh di sini sudah kan? Okay, so what is being experienced by this block here is it will experience a velocity. Okay, a value adalah velocity dia just before it strikes the spring. Okay, so after that pula kita akan ada the gravitational potential energy to be equal to 0. Sebab sekarang ni dia berada di reference line. Okay, so bila ada velocity, there will be a kinetic energy lah. It will experience kinetic energy. Okay, so after that pula we have to consider the situation where the spring is now compressed lah. Okay, so contoh lah dia sudah kena compress, and then it goes down till here. So this top end of the vertical spring is somewhere there lah. Okay, dengan the along with the block here. Okay, so we are gonna calculate this value of x. Okay, kenapa dia? Okay, so we have to calculate the value of x here. Alright, so let's just do try to do A dulu lah. Okay, so for question A, we are gonna apply both of the questions, both A and B, we are gonna apply conservation of energy lah. So the total initial energy should be equal to the sum of the final energy lah. Okay, so we know that for this block sahaja, for this situation, jangan tengok yang spring dulu lah. For this situation, there is only kinetic energy and gravitational potential energy. Okay, so now you are going to write mghi plus half mu square equal to mgh final plus half mv square. So we are looking for this v lah. Okay, so since we are talking about the block, m should be the same for each of this m lah. Okay, mestilah sama. Okay, so now hi is equal to 0.3, so there is a value. For u is going to be equal to 0, so this thing will be equal to 0. I'm just going to highlight this, and then this one should be equal to 0 as well. Okay, so kenapa equal to 0? Because the initial velocity is 0. Kita sudah declare di sini. Kenapa? Sebab sekarang ni dia tidak kena buang. Dia just kena letak and then dia fall down. So the initial velocity should be 0 lah. And then our reference point is here. When the block falls, it lands on this this plate, sorry, no, the top end of the spring. So kita akan letak H equal to 0 sebab dia berada di reference line. Okay. So from there you will be left with, besar. You will be left with GHI equal to V square over 2. Okay, so dari sini kamu akan dapat 2.43 meter per second. Okay, try to solve it sampai kamu dapat that answer lah. Okay, so that is the velocity before it strikes the top end. Okay, right, now baru kita akan consider for the compression lah. So yang ini, this is for the second situation, which is sorry, this is for the second situation where we are gonna consider untuk the spring lah and the block, the spring and the block, this situation here. Okay, so bila ada spring, kita punya what is it called, our equation of conservation of energy, ada an additional apa tu nama dia, elastic potential energy lah. Okay, so elastic potential energy is let me just write it down first. Kinetic energy, kita ada potential energy, gravitational potential energy, and then we have, what is it, oh, U as initial, and we have final, U final plus U as final. Okay, so I'll expand them first. So this is half. Why I write V here, sebab sekarang ni the velocity before it strike this plate should be the same, should be the initial velocity before they compress this spring. Okay, all right. So this is mghi plus half kx square equal to half mv square. I guess I have to label it that way lah. Mgh final plus half kx square. Yeah, okay, so now let's look at this part here yang belum lagi dia compress. Kita tengok ini dulu. Okay, so this is the initial, right? So for the initial part, is there any gravitational potential energy? No, because this is at the reference point. So we can say that this one equal to 0. Next, we have to look at the potential, elastic potential energy. So the spring is in equilibrium. No, in equilibrium lah kan? Okay, it's in equilibrium. It is not stretched or compressed. So x is equal to 0. So kita akan dapat tinggal, this is 0. So initial tinggal lagi half mv square. Kenapa ni tidak kosong? Sebab tadi kita sudah kira v is 2.43. Okay, so bolehlah kita letak sana mv square over 2. Jangan confuse aja, I just put over 2 di bawah sini. Okay, so now kita tengok pula final, right? So untuk final, we are gonna consider when the block ni compress sudah dia. Okay, so what is happening here? Okay, so if we look at it, is there any kinetic energy here? Okay, so there is no kinetic energy here because at maximum compression, there is no other velocity yang cause it to move. Okay, dia sudah kena compress ni sekarang. Velocity ni kosong sudah. Okay, so kita akan letak di sini velocity. Velocity at this point should be equal to 0. Sebab sekarang ni dia kena compress. Kalau kamu compress a spring, dia akan move lagi kah? Tidak kan? Sebab kamu sudah make it stop. It stop sudah. Tidak sudah movement. Macam itulah. Okay. And then next we have to consider for what? We have to consider for the gravitational potential energy. So the gravitational potential energy, this is your reference line. This is your value of H. Okay. Label lo. Nanti kamu tupi ambil yang di atas punya. Okay. So that is your value of height, the final height. Okay, so what is this value? It is the value of x. Okay, and then sekarang ni from the reference point, it is pointing downwards, so it should be negative x lah. Okay, so this is negative x. Okay, jangan confuse kenapa negative, sebab sekarang ni reference line kita di sini and this is pointing downwards, so it should be negative. Okay, and then kenapa x? Sebab sekarang ni the spring is compressed up until this point saja. Okay, so kita punya nilai h pun mestilah ikut the top end of the plate. Okay, alright. Lepas tu kita perlu apa lagi? Okay, kita perlu this one. Okay, this one memanglah ada. Right, so from that just now kita sudah conclude there is no kinetic energy, so we are left with mgh plus half k x square. Okay, so dari sini cuba kamu substitute. M is can we cancel m? No, cannot. So m is 2, v is 2.43 square divided by 2. This is 2 9.81. This is negative x plus half 2000. This is x square lah. Okay, so you will obtain a quadratic equation. Something like this. So you will get x equal to 0.087 meter. Okay, right. So the only thing that is different from question A here is the presence of apa nama dia ni? Elastic potential energy. So please remember kalau ada spring, kamu perlu consider the elastic potential energy. Alright, so that is the solution for question number 7.